Well, let me say thank you very much for this very kind invitation to speak to the Leopoldina today on the subject of Schrödinger and Heisenberg and their complicated nominations for the Royal Society. And the theme of my talk is going to be about should politics be involved when an eminent scientist is nominated for election to a prestigious society. That will be the main topic of my discussion, of interest to the Leopoldina, I expect, and certainly to the Royal Society. Now, the Royal Society was founded in 1660 by King Charles II after he received some demonstrations in science from Robert Hooke and Robert Boyle. The Royal Society claims to be the oldest national science academy of continuing time. It is, though, not as old as the Leopoldina, as I understand it. So there's quite close connections. The Leopoldina, I think, was founded 8 years before the Royal Society. Now, a key aspect of the Royal Society is that it has what's known as a charter book. That's here on the left, which has been signed by all members of the royal family since 1660 and all fellows of the Royal Society. So it's a great autograph book. It's been signed by the great British scientists such as Isaac Newton here, Charles Darwin here. All members of the royal family have signed it, and we will come back to this important charter autograph book during the talk. Now, there are really two main classes of fellows of the Royal Society. The FRS, the normal fellows, are people who are based in the British Commonwealth. So that's not just the UK, it includes other countries like Canada, Australia, and South Africa, and others. And people who are from other countries, citizens from other countries, who are elected to the Royal Society are known as foreign members. And I'll be discussing the foreign member nominations today, in particular of Schrödinger and of Heisenberg. Now, in the old days, to be nominated for a foreign membership of the Royal Society, there's a special book called the Foreign Members Book. And somebody's name and the case had to be handwritten in the Foreign Members Book, which is a fascinating archive to look through. And here's just a few examples. They're handwritten of well over 100 or more years ago of some famous scientists whose cases were put into the Foreign Members Book. So up here on the left is the nomination made by J.J. Thomson, the discoverer of the electron, of Ludwig Boltzmann in 1899. And Thomson said he was the author of important research on the kinetic theory of gases. And Boltzmann was elected in 1899. Then after the First World War, there was a very important nomination, Albert Einstein. He was nominated for being the founder of the theory of relativity. And this was very important because this was just after the First World War, and it was thought to be a friendship nomination, bringing in a German scientist, the first one after the First World War who was working in Germany, Albert Einstein. It's very hard to get elected to the Royal Society. Here's Paul Langevin, who was nominated but was not elected. And then in 1925, the next physicist to be elected doing theory was Niels Bohr for his work on the quantum theory, as you can see here. And that was also written in a year. He was elected straight away, or a year later. And then Max Planck, he was elected. But you see this Hermann Weyl here was nominated at the same time as Planck, and the initial nomination for him lapsed. So it's hard to get in as a foreign member of the Royal Society. And here are the 5 theoretical physicists who were elected as foreign members of the Royal Society from 1899 right up to the 1920s. Boltzmann, Einstein, Bohr, Planck, and Sommerfeld. Now, you might think Sommerfeld perhaps isn't quite in this group, but back in the 1920s, he had a really excellent reputation, nominated for the Nobel Prize 82 times, more than anybody else who never won that prize. And he had a really outstanding reputation. So this is the example of the prestige of being elected in those times as a foreign member of the Royal Society. Now, Paul Dirac's view was that both Heisenberg and Schrödinger should be added to this illustrious group. And so in the 25th of January, 1945, during the Second World War, Dirac nominated Heisenberg, and this is his nomination in the foreign members' book. Heisenberg, the founder of quantum mechanics, which has revolutionized the whole of atomic theory and provided a reliable basis for the investigation of atomic phenomena. That's what Dirac wrote, amazingly, during the wartime. And he also wrote on Schrödinger, saying he showed how the energy levels of the hydrogen atom may be calculated as the eigenvalues of a vibrating system. So Dirac thought very highly of both Heisenberg and Schrödinger and thought they should be both added to this illustrious group of people from outside of the UK who should be foreign members of the Royal Society. And here is Schrödinger. He is, of course, born in Vienna, and his great work, Schrödinger's great work, was in 1926 when his Schrödinger equation was discovered and he introduced wave mechanics. That was his great year. And it was immediately realized by the great physicists, especially in Germany, how important this was. And he moved to Berlin then as the successor to Max Planck, to a very prestigious chair. But after Hitler came to power, Schrödinger was not pleased. He was not Jewish. He did not have to leave Germany, but he decided he would. And he came to my own college, Magdalen College, Oxford. And the day he arrived at Magdalen College, Oxford, he heard he'd won the Nobel Prize with Paul Dirac. Things didn't go very well, though, for Schrödinger in Oxford. He was hoping for a chair, a statutory chair, and the person in the chair did not retire or die. And so a position couldn't be found for him, and he rather foolishly moved back to Austria to the University of Graz in 1936. And then just 2 years later, in 1938, we had the Anschluss in Austria, and he was in a difficult situation because he had already left Germany. And Schrödinger then managed to escape to Rome, and then Oxford, and then Belgium. And then the war started while he was in Belgium, so he had to escape then to Dublin, where he spent the Second World War and wrote a famous article called What is Life? And he returned to Vienna in 1956. So that is a very quick summary of Schrödinger. Here's a few photographs of Schrödinger. The one on the left-hand side is Schrödinger in the garden in Oxford. Professor Lindemann, the gentleman there, came to Berlin in 1933 and got several of the Jewish scientists in Germany to come to Oxford. And he also persuaded Schrödinger to come. And there is Schrödinger. And there is Schrödinger also just outside the house where I used to live until recently, the President's Lodgings in Magdalen College in Oxford, where he heard he had won his Nobel Prize. And all of this is described in my book, Schrödinger in Oxford. Now, Heisenberg, the other character we're going to discuss, was a little bit younger than Schrödinger, and he was trained with first Sommerfeld and worked as an assistant to Max Born in Göttingen. And then his great paper, almost exactly 100 years ago, on quantum mechanics came out in 1925, the start of quantum mechanics. He was a professor then in Leipzig, and he won the Nobel Prize at the same time as Schrödinger. It was the Nobel Prize for 1932, and he heard about it in 1933. But the difficulty with Heisenberg was that he took part in the German nuclear research program during the Second World War. And that has caused a lot of problems with other scientists later on that I'll be discussing. But after the war, he came back to Göttingen as a professor, and then he was involved in important work in helping to establish international scientific initiatives such as CERN, the Max Planck Institute, UNESCO, and so on. And he did good work and then died in 1976. These are the two great papers that won the Nobel Prize for Heisenberg and Schrödinger. The first one on the left is the proof of Heisenberg's paper, is actually the proof of Paul Dirac. It was sent to Dirac's supervisor, Ralph Fowler, in the summer of 1925 by Heisenberg, and Fowler passed it on to Dirac. And you can see what Fowler said to Dirac. "What do you think of this? I shall be glad to hear." And this was the paper that changed Paul Dirac's life, because he immediately realized that there is a new theory of quantum mechanics. And this paper on the right is Schrödinger's great paper when he introduced the Schrödinger equation and wave mechanics just a few months after Heisenberg. These are really the two great papers of quantum mechanics that introduced this subject to us, and people have found so useful ever since. So this is Paul Dirac, a British scientist, a great British scientist. He wrote the first thesis on quantum mechanics in 1926, when he also introduced Fermi-Dirac statistics. And then his famous relativistic equation was published by Dirac in 1928. This was based both on Heisenberg's work and on Schrödinger's work. And for that reason, he really very highly rated both Heisenberg and Schrödinger. Out of his equation, for example, the positron and antimatter was predicted. And so at the very young age of 28, Paul Dirac was elected Fellow of the Royal Society. And then he was given the Lucasian Chair of Mathematics in Cambridge, the chair of Isaac Newton. And he jointly won the Nobel Prize with Schrödinger in 1933. So there was a very close connection between Dirac, Schrödinger, and Heisenberg. And at the famous Solvay conference of 1927, all of these characters were present when the new quantum mechanics was really first discussed by the great physicists. In the back row, there is Schrödinger here. Just nearly next to him is Pauli, and a little bit further to the right is Heisenberg. And then in the second row, right in the middle, is Paul Dirac. If you look along a little bit further, you will then see Max Born and Niels Bohr to the right. And in the front, Einstein, Lorentz, Marie Curie, and so on. This was the great conference when quantum mechanics was the subject, and it really came to the fore and was accepted by all these other great scientists. And also on November the 9th, 1933, these are the 3 telegrams that were sent from the Royal Swedish Academy of Sciences. The first one on the right to Heisenberg, telling him he had won the Nobel Prize for 1932. The one on the left for Schrödinger, sent to him in Oxford, but in German, saying he'd won it with Paul Dirac, and the one below in English, saying the same thing, but in English, to Paul Dirac in Cambridge. These are the three great telegrams that were sent to tell these scientists that they had won the Nobel Prize. And then they all got together in Stockholm in 1933. This is the famous picture of them with Schrödinger's wife and the two mothers of Dirac and Heisenberg, all together to get their prizes. So there was a special bond, particularly between Dirac and Heisenberg and Dirac and Schrödinger. But the question then came when Dirac nominated Heisenberg and Schrödinger for foreign membership of the Royal Society in 1945 at the end of the Second World War. And there were three important professors who had left Germany and all managed to obtain chairs, professorships in the UK, who had a very important influence on science in the UK in the late 1940s, or in the middle 1940s as well. And the first of these was Max Born. He came from a family of Jewish descent. He studied under Hilbert in Göttingen, and then eventually had his own chair in Göttingen, and his assistants there in research included Heisenberg, Pauli, and Fermi. Wouldn't any scientist like to have had those three as research assistants? And after Heisenberg had his great paper, Born realized that in Heisenberg's paper, there was a statement that if you apply momentum and coordinate, it doesn't equal coordinate and then momentum. And Born at once realized that this was also expressed in matrix multiplication. So he wrote a paper with Jordan, and then another paper with Jordan and Heisenberg that became called the matrix form of quantum mechanics. But it was Born who really introduced the idea of the matrix, and it was Born who was the first one to use the phrase quantum mechanics, which was an advance on Planck's quantum theory. And then Born did write the first papers on quantum scattering theory a year later, and it was those that led to his Nobel Prize some nearly 30 years later. But because he was Jewish, he was given a temporary lectureship in Cambridge. He felt he had to leave Germany when Hitler came to power in 1933. And like Schrödinger, he was only given a temporary position and it didn't become permanent. But in 1936, a chair became available of mathematics in Edinburgh. It was first approached to Schrödinger, but he was already on it thinking of going back to Austria. So it was offered to Born and he accepted the chair straight away. And just 3 years later, he became a British citizen and was elected at once a Fellow of the Royal Society. So he could nominate and support or deny other people for election to the Royal Society. Eventually, he went back to Germany in 1954 and then won the Nobel Prize for his statistical interpretation of quantum mechanics, which came out of his quantum scattering theory papers. So Max Born was a very influential theoretical physicist in the UK in the late 1930s and through the 1940s. Now, these are two interesting letters that were sent both to Born and to Schrödinger when Born was in Cambridge in the summer of 1935 and Schrödinger was in Oxford in the summer of 1935. They're almost identical letters, but not quite. The letter on the left was sent to Max Born. It says in Göttingen, but he was in Cambridge, and it was sent from Berchtesgaden. The letter on the right was sent to Schrödinger, and it was sent from Berlin. And the reason why these letters were sent is that professors in Germany at that time were appointed by the Chancellor of Germany. And if they were released from their chairs, they had to be released again by the Chancellor of Germany. So these two letters both say, that this one is to Schrödinger, I've translated it into English. According to your request, I leave you with effect from the end of March 1935 of your official obligations in the philosophy faculty of the University of Berlin. I express my thanks to you for your academic achievements and for the services you have performed for the state. Your Führer und Reichskanzler, Adolf Hitler. So both Born and Schrödinger, when they were out of Germany in England, received these letters from Adolf Hitler. There was a special friendship and link between Max Born and Schrödinger. But there were two other important professors who left Germany who are part of this story. And this is Rudolf Peierls. He was born in Berlin. He worked with Sommerfeld, Heisenberg, Pauli, and Fermi. Never got a position, though, in Germany or elsewhere in that part of Central Europe. And he got a fellowship to come to Cambridge from the Rockefeller Foundation in 1932. And then Hitler came to power. Peierls was from a Jewish family and didn't want to go back to Germany. So he then went to Manchester. And then at the very young age of 29, got a chair of applied mathematics in Birmingham in the UK. He then became a British citizen in 1940. And then he had a very, very influential work. With Otto Frisch, he calculated that a nuclear bomb could be made from a small amount of uranium-235. That proved to be a very important finding that started off, or helped to start off, the Manhattan Project in the United States, where he worked. But he came back to England in 1945 and was elected Fellow of the Royal Society. He was made the Wickham Professor of Physics at Oxford University, and 5 years later was knighted by the Queen. So he was very much part of the British scientific establishment, Rudolf Peierls. And then the third professor who came from Germany and came to the UK and was very important in this story is Francis Simon. He wasn't a theoretical physicist, he was a physical chemist. And he worked with Nernst on low temperature heat capacities, where Lindemann, the professor in Oxford, worked also. And then he became a professor of physical chemistry in Breslau, but he came from a Jewish family, so he had to leave Germany in 1933. When Lindemann came to Germany, he saw Simon and convinced Simon to bring his whole research group on low temperature physics to Oxford University in 1933. His position wasn't permanent, but in the end it was made permanent in 1936 in Oxford. He was made a British citizen, and then associated with the work of Peierls, he developed the gaseous diffusion method for separating uranium-235 and uranium-238. This is a very important development. It showed these isotopes could be separated, and in the Manhattan Project in the United States, it was scaled up on an industrial scale. And the bombs that was dropped on Hiroshima was used from uranium-235. And like Peierls, Simon worked on the Manhattan Project in the USA. When he returned to England, he was elected a Fellow of the Royal Society. He was knighted by the Queen, and he became the Dr. Lees Professor of Physics at Oxford. So just like Peierls, he became a pillar of the scientific establishment in the United Kingdom. And so in the late 1940s, Born, Simon, and Peierls were very influential in the UK. Any nomination for a Fellow of the Royal Society or a foreign member of the Royal Society from Germany had to get the support of these three scientists. Now, I'm going to show you quite a few letters now, and these are all the acknowledgements for the letters, documents, and photographs. I'm not going to go through them in detail, but I did have a lot of help from the daughter of Schrödinger, Ruth Brownitzer, who provided several documents for me, including that one from Adolf Hitler, and also Gustav Born, who was a student once in my college, Magdalen College. I had both Ruth Brownitzer and Gustav Born staying with me in Magdalen College some 17 years ago, I think it was. And that was the first time that they could remember meeting. And they provided a lot of useful information for my books, as did all these various other institutions and peoples and children of these famous scientists. I'm now going to go through some interesting letters that I came across. Of all the letters, though, that I came across, this is the one that I find most remarkable. The date, June the 4th, 1940. It's a letter from Francis Simon in Oxford to Max Born in Edinburgh, the 4th of June, 1940. This was when the British troops on this day were being evacuated from Dunkirk. It's when Winston Churchill gave his most famous speech in Parliament, "We will fight them on the beaches." Yet Simon was allowed to send a letter through the normal British mail. It was in English because there could have been censored otherwise, about what was going on and his thoughts in Oxford. And I'll read out what he said. Dear Born, it will be of interest to you to hear, if you have not heard already, that the uranium bomb seems to become a practical proposition. It has been proved experimentally in America that uranium-235 is responsible for the fission phenomenon. Frisch and Peierls have calculated that a mass of a few kilograms of uranium-235 would blow up, and that the times will be quick enough to show a real detonation. Of course, one cannot predict this with absolute certainty, but they believe that the probability is about 50%. The chief point is to separate the isotopes. This is possible with very much money, the order of £1 million, but it will be worthwhile as it could decide the war. The point now is to separate as quickly as possible a few milligrams, and to develop the methods for separating kilograms. I have tried hard since the beginning of the war to persuade Lindemann to let me go on with this matter on a biggish scale, as I always believed that something could be prepared for the U-bomb in case it should work. And then he says at that time he had no success in getting support for his work, but eventually it did come. And he also says, I'm afraid that even a man with this vision, like Lindemann, would support the scheme, but it will not be possible. And so it's a remarkable letter because it says everything that happened that led to the Manhattan Project. You could create a nuclear bomb with a small amount of uranium, and he had the idea for separating uranium-235 and uranium-238. And what is remarkable about this letter is it was sent through the English mail with no censorship from Simon in Oxford to Born in Edinburgh. If Heisenberg or von Weizsäcker or Dibner or any of the other physicists working on the German nuclear program had seen this letter, how different things might have been. And in the end of the letter, Simon does say he thinks the Germans already know about this and will be able to produce a nuclear weapon. Anyway, back to the nominations of Schrödinger and Heisenberg. And this is about Heisenberg's nomination to the Royal Society. And this is a letter from Born to Simon on the 25th of February, 1945, still during the Second World War. And Born says to Simon, when I was at the Royal Society meeting in London in January, Dirac asked me to enter the name of Heisenberg in the list of candidates for foreign membership together with him. In the first moment, I was so embarrassed that I agreed, but withdrew after some consideration to Dirac's astonishment. He said, "Dirac's discovery will be remembered long after Hitler is forgotten." That may be true, but I'll feel unfaithful to Bohr, Kramers, Langevin, and many others who have suffered, and to my own relatives, if I should bestow an honor on a German. After the war, when guilt and merit can be decided, it will be another matter. What do you think? Said Born to Simon. And Simon replied at once, I think you're absolutely right in refusing to suggest Heisenberg for foreign membership of the Royal Society. It is true members or foreign members should only be elected according to their scientific merits. Particularly, however, with the foreign members, other qualities have to be considered also to choose between the very great number of possible candidates. I think at the present moment it is completely out of place, to put it mildly, to suggest Heisenberg, who after all behaved very badly as a person. So this was the view, the very strong view that Simon and Bohr had because of Heisenberg's activities. And also, and Born says this in the following letter to Simon, concerning Heisenberg, I had further news about his bad behavior. 2 Belgian scientists were here, De Hemptien and Junger from Louvain. They told me, amongst other things, that Heisenberg has visited Holland during the first half of the war, just after Stalingrad, at the invitation of pro-German professors. And there he met Kramers, who did not belong to these, but could not avoid meeting him. They spoke about the war, and Heisenberg admitted that it was probably lost Stalingrad, but added, well, the next war we will certainly win. So the feeling of both Born and Simon is just how insensitive Heisenberg was when he visited under occupation these other countries in Europe, such as the Netherlands, and also, of course, famously when he went to Denmark to see Niels Bohr, and they thought very insensitive. And that, in a way, upset Born and Simon more than anything. And also, Peierls came into this discussion a little bit later. Peierls had been a student with Heisenberg, but nevertheless, he was very negative. I feel one must be careful about pressing for admission of people like Heisenberg, since I believe that for the resumption of international contacts, it is essential that people should be made to understand the distinction between the behavior of people like Lau and Hahn, of whom one hears from all sides that they have kept aloof from all government activities and have resisted any attempts to ingratiate themselves with the Nazis, either by collaborating or making public statements, and the others of whom this seems much less clear. And then Simon wrote to the President of the Royal Society, Henry Dale, and said, Heisenberg is, of course, one of the greatest living scientists, but on the other hand, he is also a very shrewd politician and was always a nationalist of the first order. He has never been a real Nazi, but he was quite prepared to share the spoils, one might call him a fellow traveller. And so Heisenberg's nomination with these sorts of statements went right through to the Royal Society president, and his nomination was not successful for being a foreign member of the Royal Society at that time in the 1940s. Now, what about Schrödinger? Going back to Schrödinger. Well, his nomination went to the Royal Society and went to the Mathematics Committee. And the chair of the Mathematics Committee was Douglas Hartree, who himself had made a famous development with Schrödinger's equation to allow it to be used for calculating orbitals, still used to the present day, and called Hartree-Fock theory. And he was chair of the Mathematics Committee of the Royal Society. And he was really concerned what the members of the Council of the Royal Society, who is the final committee that had to recommend Schrödinger for election, what they were saying about Schrödinger. And this is a letter from Hartree to Paul Dirac. And it says, the council members were antagonistic, the attitude being that one hunch, however good and important the development from it, was not enough of a claim and needed more follow-up with sustained evidence of ability. Isn't it remarkable that the Council of the Royal Society, people were saying that Schrödinger just had one hunch? I think if any other scientist would have had that hunch, they would have been really pleased. So it didn't go through. And Max Born was absolutely annoyed at this when he heard about it. He wrote to Peierls, "I got today information from the Royal Society about the recommendation of names for election of foreign members. Apart from Cripps and two names unknown to me, there are Brewer and Paulin, but not Schrödinger. Dirac and I have tried for years to bring him into the Royal Society. The main obstacle is the letter he wrote in Graz, in which he expressed his agreement with the Nazis. There is hardly any paper in theoretical physics in the world where not a Schrödinger equation is used. He has actually revolutionized our science. That he was not lucky in recent years seems to me of less importance. Planck has also not done any fundamental work after 1900. Now, there in that letter, Max Born mentions a letter that Schrödinger wrote to a newspaper in Austria on the 30th of March, 1938. This was just 2 weeks after the Anschluss in Austria, when German forces marched into Austria. And Schrödinger published a letter in the local paper, the Tagespost of Graz, saying he was now reconciled with the Führer. And Nature then summarized this letter a few weeks later, as it says here. People back in England read the Nature article and they were so infuriated with Schrödinger. Lindemann, Simon, Peierls were really annoyed that Schrödinger had written a letter. The man who had left Berlin and didn't have to leave was now supporting Hitler. And after the Anschluss, it was heard back in England that Schrödinger was in real trouble. There were 3 professors who were Nobel Prize winners in Graz, and 2 of them, Victor Hess and Otto Louis, had been arrested. And it was thought that Schrödinger had been arrested. So one of my predecessors, the president of Magdalen College in Oxford, George Gordon, got on to Lindemann to ask the Foreign Secretary of Great Britain, Lord Halifax, if it would be possible to get permission for Schrödinger to leave Austria and come back to Oxford to give lectures. And this appeal went all the way up to the top in Germany. Lord Halifax then contacted Neville Henderson, who was the German ambassador. This is a picture to the right here of Neville Henderson. He arranged for the Prime Minister, the ambassador of Britain, Neville Henderson, arranged for the British Prime Minister, Neville Henderson, to come to Munich at the end of September 1938 to meet Adolf Hitler, and the famous Sudetenland Agreement was then arranged. And there is Ribbentrop, the foreign minister of Germany, in this photograph as well. But the key man here is Neville Henderson, who was the ambassador to Britain, and was indeed the man who delivered the letter to the German government on the morning of the 3rd of September, 1939, saying if troops were not withdrawn from Poland, then Britain would be at war with Germany. So Neville Henderson was an absolute key player. And he asked Ribbentrop if it would be possible for Schrödinger to get permission to leave Austria and come back to Oxford. And this was the reply from Ribbentrop. I found this telegram very recently in the British archives. And this is the translation of the telegram from Ribbentrop to Neville Henderson. On receipt of your letter of the 8th of this month on the subject of the lectures to be given in Oxford by Professor Schrödinger of Graz, I at once communicated with the German authorities concerned in the question. Unfortunately, the result is not a favourable one. I have been informed that Professor Erwin Schrödinger left Germany in 1935 for political reasons, and after a brief stay in Oxford, settled in Graz. There he proceeded to busy himself as a fanatical opponent of the new Germany and National Socialism. A recently undertaken examination of his case has confirmed the fact that he has up until very lately remained in constant communication with German émigrés living abroad. It is therefore to be feared that permission for him to go to Oxford would merely offer him a further opportunity to take up once more his anti-German activities. In these circumstances, I am unfortunately forced to the conclusion that a course of lectures by Professor Schrödinger in Oxford could bring no profit to Anglo-German relations. So this was the letter from Ribbentrop to the British ambassador that went all the way back to Lindemann and Gordon in Oxford. Schrödinger was then in a very difficult position. He was fired from his position in Graz. He was fired from his honorary professorship in Vienna. He escaped to Italy with his wife, where he stayed in the Pontifical Academy of Sciences, and then went back to Britain, and he was not accepted by the British scientists. Lindemann said he'd have nothing to do with Schrödinger because of that letter he'd written to the newspaper in Austria. He was homeless, Schrödinger, for a time in England. He lived for a few weeks with Paul Dirac in Cambridge, but then he was given a temporary position in Belgium, and he went to Belgium. But to go to work in Belgium, he had to get permission from the Belgian police, and they had to go back to Graz to say, had Schrödinger behaved himself in Graz, in Austria? So there's this interesting letter here from the police in Graz to the police in Belgium on Schrödinger's behavior. And this was a letter sent in April 1939, nearly 9 months after Schrödinger had left Austria. And it says, translated, Professor Erwin Schrödinger, last resident of Graz, was opposed to the National Socialists during the system era. However, on May the 30th, 1938, March 30th, 1938, he announced his remorseful allegiance to the National Socialist state in the newspaper, and there is no currently evidence against him. So at least because of that letter Schrödinger wrote, he had this favorable report from the police in Graz that enabled him to get a work permit to work in Belgium. However, he wasn't there for long because the war started, and he managed then to get an appointment in Dublin. And he there had a really nice time. The best place to be, Second World War, was Dublin. And there he is with Max Born, who invited over in 1943 during the war. And below, just after the war, he had a celebratory conference. At the left is Max Born, in the middle is Paul Dirac, and at the end is Schrödinger. So he had a nice time in Ireland during the war, despite all the previous difficulties. But nevertheless, this is what Peierls was saying about Schrödinger to Max Born. As regards Schrödinger, there is, of course, no doubt whatever his merits as a scientist. The issue is, however, whether scientific distinction is the only factor to be taken into account in the election. On grounds of personal record, I think there is a very strong case against Schrödinger. The famous Graz letter is only one example, but it is bad enough. Born immediately wrote to Simon, saying, Schrödinger has again not been elected foreign member of the Royal Society. There must be strong opposition, and I found out that Peierls belongs to it. Schrödinger is a difficult fellow and gets on people's nerves. But in the whole world's physical literature, there is hardly one paper without a Schrödinger equation. So Born was still fighting for Schrödinger, even though Peierls and Simon were not. And Simon says a few words about Schrödinger. I am not of your opinion that his treatment by the Royal Society is an outrage. I am quite sure that if the Germans had won the war, that Schrödinger would have written another letter saying he'd been mistaken and that after all, the Nazis were the right kind of people. To qualify for foreign membership, it is not sufficient just to have the scientific standing. The person must have some additional merits, and you must admit that Schrödinger has not made it very easy for them to see his specific methods. I do not think you fully realized how he behaved when he was in Oxford. Everything in England was wrong, from the bicycle brakes and doorknobs to many important things, and only things in Germany were right. So Simon was dead against Schrödinger. But in 1949, the Mathematics Committee had the chair Hartree. And of course, he was a great supporter of Schrödinger. And on his committee was Leonard Jones, who was also used Schrödinger's work in his molecular orbital and intermolecular forces theory, and Harry Massey, who had written a book with Neville Mott on applying Schrödinger's theory to scattering of electrons and atoms and molecules. So there suddenly was very strong support on this committee. And George Thomson, the person who had discovered that the electron was a wave and not a particle, the son of J.J. Thomson, who discovered it was a particle, wrote in the foreign members' book that Schrödinger was the first to derive the original idea of de Broglie, a workable calculus which gave wave mechanics definite form. And Thomson had just won the Nobel Prize for discovering the electron was a wave, and had indeed been nominated by Schrödinger for that. With all these supporters, Schrödinger's nomination now went through and was successful, and he was elected a foreign member of the Royal Society in 1949, 4 years after being nominated by Paul Dirac. And he was so delighted. This is the letter that he wrote to Paul Dirac just after he heard he was elected a foreign member. Many thousand thanks, says Schrödinger. It was awfully good of you to manage this difficult problem in this fashion. You really are very nearly a saint. Any non-saint would have just got cross with me and done nothing more. I'm very glad and grateful for this gracious form of clinching my sentimental attachment and true devotion to British science and learning. There's a little bit of sarcasm, which was typical of Schrödinger in that, but he nevertheless was really delighted. And then just a couple of years later, he went to the Royal Society and signed the charter book, signed by all the kings and queens of England previously, signed by Isaac Newton and Darwin. And you can see in the second column, third down, there's the name Erwin Schrödinger. Signed the book next to Chandrasekhar, who was to win the Nobel Prize for black holes. And a little bit further down here is the signature of A.M. Turing, Alan Turing. He signed the charter book at the same time as Erwin Schrödinger. And indeed, Annie Schrödinger, his wife, wrote to her great friend, Lise Meitner, to say that Schrödinger was delighted to now be a foreign member, together with his friends Max von Laue, Einstein, Planck, and Sommerfeld. So there was a conclusion to this story. Now, going back to Heisenberg, this is a brilliant photograph. Dirac on the left, Heisenberg in the middle, Born on the right. And Dirac is kind of saying to Born, come on, we've got to elect Heisenberg to the Royal Society. And Heisenberg in the middle is a bit bemused by it all. Well, nothing happened for about 3 or 4 years until 1952, when John Cockcroft, who had won the Nobel Prize for splitting the atom, he was one of Rutherford's group, wrote to Dirac and said, why don't you nominate Pauli for foreign membership of the Royal Society, Wolfgang Pauli? And Dirac then replied, no, I won't nominate Pauli because I consider Heisenberg to be more eminent. Heisenberg and Pauli were only separated by 1 year. They'd both worked with Sommerfeld, with Bohr, and with Born. They both had great principles associated with their name, one on uncertainty and one on exclusion. They were competing for their whole life together, really, and both were Nobel Prize winners. Heisenberg won it first and then Pauli. But Pauli was then nominated for foreign member in the foreign member's book, saying he was distinguished for important contributions, in particular the exclusion principle. And there he is with Dirac and Peierls, who worked with Pauli, and then Pauli was elected before Heisenberg. But in the meantime, Heisenberg had done very good work in Germany. He'd become involved on the board of CERN, UNESCO, the Max Planck Institutes, the Humboldt Fellowships. He'd done perhaps more than anybody to help re-establish science, rebuild science in Germany and in Europe. And this was realized by the Mass Committee, who recommended that he should be elected a foreign member of the Royal Society. This went to the Council of the Royal Society, and he was competing there with Lise Meitner. And she was elected, and so was Heisenberg. She was the first female to be elected a foreign member of the Royal Society. But Heisenberg was finally elected, and this was the form that showed his nomination went through. 10 years after the nomination by Paul Dirac, Heisenberg was finally elected a foreign member of the Royal Society. And what had happened in the Second World War, the emotions had somewhat diminished, and he was elected. So this shows you how politics and science can interact, and this happened in the 40s and 50s. But what happens in modern times? I'm now going to fast forward to 2018. Here is the list of people elected to the Royal Society in 2018. These are the signatures in the charter book. And if you go down here, just near the bottom, is the signature of Elon Musk. Elon Musk actually was South African born, and because South Africa is in the British Commonwealth, he could become a normal fellow of the Royal Society. And he was elected in 2018 for his contributions to batteries in the electric car. However, just 2 months ago, there was a petition drawn up by over 1,000 scientists that Elon Musk should be expelled from the Royal Society because of all the anti-science activities that he was taking part in the new administration in the United States. So the Royal Society, very unusually, and they've never done this before, had a full meeting of all fellows to discuss the proposal that Elon Musk should be expelled from the Royal Society. However, the decision was taken that they shouldn't interact politics and science and should not take disciplinary action against Elon Musk. And he remains a fellow of the Royal Society. So there were difficulties with politics and science back in the 1940s and 50s at the Royal Society. And those complications are continuing to the present day. And if you want any more about this story, I've written an article about it called Foreign Membership of the Royal Society, which was published in the Royal Society Journey of the History of Science, Notes and Records. And also there's some background material in my book Schrödinger in Oxford and the Lost Scientists of World War II. And thank you very much again for your attention.